All right, let's now work on example 2 here, which says a printing company bought a new printing press for $15,000. The flat rate depreciation is 12% per annum. By how much is the printing press depreciated per year? So first things first, we're dealing with flat rate depreciation, which means we're losing 12% per annum of the original each year. So 12% of the original cost each year. That's what flat rate depreciation tells me. So to figure out how much I'm losing per year, I'm going to have to figure out what 12% of 15,000 is. To write that, I go 12 over 100, 12 over 100, and then times that by 15,000. That's how I find what 12% of 15,000 is. So I go control, divide 12 over 100 times 15,000. What I think is a bit of a quicker way to do this is simply to go 0.12 times 15,000. Same thing. 12 on 100 is the same as 0.12. That's 1,800. Each year, we're losing $1,800 worth of the value of this printing machine. Question B here then says, we need to write a rule. So we're writing a general rule for the value of the printing press, P of n, after n years. This is where we need to remember how it is that we construct our general rule. So P of n is going to be equal to, well, the original cost of it. So it's originally valued at $15,000. And then each year we're losing $1,800 of that. And we're going to times that by n, where n represents 1 year, or the amount of years rather. So this is saying 15,000 minus 1,800 times n. So n is the amount of years. Now, moving on to part C, we can use this rule, so use the rule, to determine the value of the printing press after 6 years. So that means what I can do here is I can say, all right, well, what's P of 6 when I put 6 into this? It will be 15,000 minus 1,800 times by 6, because into that n spot, I'm putting 6. You can write it like that, or you could just like pop it in like this, whatever you like, times 6. If I do that, I would now come here and I would go 15,000 minus 1,800. So it's, yeah, 800 times 6. And that means it's going to be worth 4,200 after 6 years. And remember, this is equivalent to doing what our recursion was doing before. We were doing 15,000. That's 20 zeros. Yep. And then I was minusing 1,800. And I was just doing it 6 times. 1, 2, 3, 4, 5, 6. Now we've saved ourselves that trouble. We've just gone, well, what's 1,800 times 6? And subtract all that away from 1,500. Hopefully you can see the logic of using a rule when doing this. Now here's where rules become really powerful. Part D here, where it says, if the printing press was to be written off when its value reaches 2,400, use the rule to determine use the rule to determine after how many years this will occur. This is where we're really going to use our rule effectively here. We want to figure out when our rule hits 2,400. So I'm going to say, all right, 2,400 is equal to our rule. So I'm taking that value and I'm setting it equal to our rule. Now what I want to do is I want to solve this. So I want to solve it. So what we're going to put into our calculators, and you can write this in maybe in a different color, is I'm going to put into my calculator, we want to solve this for n. So in other words, when is my n, what value will my n be in order for this to be equal to 2,400? So it would come to our calculator. We go menu, 3, 1. We type in 2,400. We then go equals 15,000, 1, 2, 3, minus 1,800. And now we don't have to use n. You can use whatever letter you like. You use x. So I like using x because I know where it is. There's x again. So I'm going that, comma x. And I'm going to say, oh, now this is where we're going to use a bit of common sense here. It's saying -5. Does that seem right? It does not seem right. That must mean we've put something in wrong here somewhere. Oh, would you look at that? I put too many zeros there. So make sure you are using a little bit of common sense. That was 24,000, not 2,400. It's 7. So n will be equal to 7. And therefore, that means it's going to be 7 years. Perfect. Hopefully that has made sense of how to use a rule. Very important stuff here.